This video deals with the topic of linear inequalities in one variable, but before we delve into that, we're going to quickly review number lines. Now here's an example of a number line. In this case, numbers range from -4 to 4. But the key thing to note about a number line is that numbers increase from left to right. As you can see, -4, -3, -2, -1, 0, 1, 2, 3, 4. The numbers are getting bigger from left to right, but the numbers decrease from right to left. So that's one thing. The other thing to note is that for any given number on a number line, numbers that lie to its right are larger in value. In contrast, numbers that lie to its left are smaller in value. So if you take a number, for instance, like 0, all numbers to the right of 0 are larger than 0. All numbers to the left of 0 are less than 0. Pick a number -3. All numbers to its right are larger than -3. So -2 is greater than -3. -1 is greater than -3. 0 is greater than -3. But -4 is less than -3. So the number line can be used to determine numbers that are greater than a specified number and numbers which are less than a specified number. So for instance, you know that 3 is greater than 2. Well, 3 lies to the right of 2 in the number line. So you can easily tell. Also, 1 is less than 2 because 1 lies to the left of 2 on the number line. Next, we're going to look at the calibration of number lines. We're going to consider what an interval is or a step size, and also what a range is. So I'm going to use this number line as an example. Now this number line has a uniform interval between each number or step size. So for instance, let's consider the interval between 0 and 1. The interval between 0 and 1 is 1 because 1 minus 0 is 1, or 0 plus 1 is 1. The interval between 1 and 2 is 1. 1 plus 1 is 2. The interval between 2 and 3 is 1. 2 plus 1 is 3. You have to increase each number by 1 unit to get to the next number. That's the way this number line has been formed. Again, we come here. -4 plus 1 is -3. -3 plus 1. Okay, I should put that here. -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. The interval of this number line is uniform, and the interval has a value of 1, or the step size, also known as step size. So the step size or interval refers to the magnitude of the difference between consecutive numbers on a number line. I'll say that again. The interval or step size of a number line refers to the magnitude of the difference between consecutive numbers on a number line. So for instance, 1 and 2 are consecutive numbers on the number line. The difference between these two is 2 minus 1, which gives 1. The magnitude of 1 is 1. Or if you consider it the other way, we have 1 and 2. The difference between 1 and 2 could be considered to be 1 minus 2, which is -1. The magnitude of which is 1. So I'll say that again. The interval or step size of a number line refers to the magnitude of the difference between consecutive numbers. The range of a number line is just the smallest and the largest value of the number line. So in this number line, the range is from -4 to 4. So in this case, the range is from -4 to 4. The interval or step size is 1 in this case. So I'm gonna put an arrow here. So the range of this number line is from -4 to 4. Or you can write it as -4 to 4. This is another form of representing it. So that's the range of this number line. So it's an easy concept. So I'll give another example. Here's a number line. 0, 2, 4, 6, 8. This number line has a range of 0 to 8, or I can write this as 0 to 8 with square brackets. This number line has an interval of what? Has an interval of 2, because the magnitude of the difference between consecutive numbers is 2. 2 minus 0 is 2. The magnitude of 2 is 2. 4 minus 2 is 2. The magnitude of 2 is 2. 6 minus 4 is 2. The magnitude of 2 is 2. 8 minus 6 is 2. The magnitude of 2 is 2. So the interval or step size for this number line is 2. So let's go through an example. Draw a number line with a range of 0 to 5 using an interval of 1. So I've taken the first step. This number line has a range of 0 to 5 because the smallest number, which lies to the extreme left, here is 0. The largest number is 5. Now we need to fill it in so that it's a complete number line with an interval of 1. For an interval of 1, you add 1 to 0, which gives 1. to get the next number. You add 1 to 1 to get the next number. You add 1 to 2 to get the next number. You add 1 to 3 to get the next number. You add 1 to 4 to get the next number. So here we have a number line whose range is from 0 to 5, alternatively written as this. This means 0 to 5, and whose interval or step size is equal to 1, because the magnitude of the difference between any two consecutive numbers is 1. 1 minus 0 is 1, the magnitude of 1 is 1. Or another way to think about it, instead of using the complicated way of calculating the magnitude of difference between two consecutive numbers, is just say, well, for a number line with a uniform interval, if I take any two consecutive numbers, if I subtract the smaller number from the larger number, I get the interval. So in this case, I'm taking the consecutive numbers 1 and 2. They're consecutive because 2 comes right after 1. Now if I take the smaller number from the larger number, which is 2 minus 1, I get 1. I get the interval. Same thing here. I get any two consecutive numbers like 2 and 3. I take the smaller one from the larger one, which is 3 minus 2. I get 1. I get the interval. So that's an easier way to calculate intervals. Here's another example question. This one says, draw a number line with a range of 0 to 80 using an interval of 20. And I've taken the first step. So I have a number line with whose smallest number is 0 and whose largest number is 80. That gives me a range of 0 to 80. For an interval of 20, I know that to get the next number after 0, I have to add 20. Because if I take the smaller number from the bigger number, I get 20. 20 minus 0 is 20. To get the next number, I add the interval. 20 plus 20 is 40. To get the next number, I add interval. 20 plus 40 is 60. And you can see that to get the next number, if I add 20, I get 80, which I've already written as the range. So this is a complete number line with a range of 0 to 80 and an interval of 20. Here's another example question. This question says, draw a number line with a range of -6 to 6 using an interval of 1. As you can see, the first step of drawing the number line has been done. The line has been drawn and the smallest number, -6, has been shown, and the largest number, 6, has been shown at the other end, given a range of -6 to 6. Now, in order to complete the number line using an interval of 1, we know that the next number to the right of -6 is given by -6 plus 1. We add 1, we add the interval to get the number to the right. So -6 plus 1 is -5, -5 plus 1 is -4, -4 plus 1 is -3, and as I keep adding 1, we can complete the number line to get these values. 2, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6. As you can see, the interval is 1. And it's uniform. Because if I take any two consecutive numbers, if I subtract the smaller one from the larger one, I get 1. I get the interval. If I take these two numbers, taking the smaller one from the larger one, so 5, taking 5 from 6 is 6 minus 5, which is 1. Considering the same thing here, taking -5 from -4 gives 1, because that's -4 minus -5, which is -4 plus 5, which is the same thing as 5 minus 4, which is 1. So we have a complete number line with a range of -6 to 6 and an interval of 1 as required by the question. This video deals with inequalities, and to start with, we're going to look at inequality symbols. This symbol here is the not equal to sign. This is the greater than symbol. This is the greater than or equals to symbol. Here we have the less than symbol, and this is the less than or equal to symbol. This is something you know. The only one you may not be familiar with is the not equal to symbol, but these are all symbols you must have come across at some point in your junior secondary school math education. Now I'm going to make a distinction between inequalities and equations. Now an equation is a statement that says that a term is equal to another term. So this statement here says x is equal to 2. This is an equation. An equation always involves the equals to sign. An inequality does not involve the equal to sign. It involves any of these symbols here. So the statement x is not equal to 2 is an inequality. The statement x is greater than 2 is an inequality. And the statement x is greater than or equal to 2 is an inequality. The statement, let's change the variable, y is less than 3 is an inequality. The statement p is less than or equal to 27 is an inequality. So these statements here, all these here, are inequalities. And why are they inequalities? Because they are stating that some term is not equal to another term, unlike equations which states that a term is equal to another term. Hence the name inequalities. Not equal. That's how you kind of remember this. That's all for inequality symbols. Now I'm going to go through some questions which will ensure, or which do test, the understanding of the 5 inequality symbols mentioned earlier. So this statement here says x is not equal to 3. And now I'm going to ask the question, x can take a value of -4, true or false? The statement says x takes values that are not equal to 3. So can x be -4? Yes, because -4 is not equal to 3. Can x take a value of 2? Yes, because 2 is not equal to 3. Can x take a value of 3? False. Or no, rather. So the response to this question says x can take a value of 3. And the response is false. X cannot take a value of 3 because the statement says that x should not be 3. X can take a value of 10. True, because 10 is not equal to 3. So that's very easy. Let's move to the next inequality symbol, the less than symbol. The statement here says x is less than 3. Given this statement, x can take a value of -4. True, because -4 is less than 3. If we take a look at a number line, -4 will lie to the left of 3, because we'll have something like this. As you can see, -4 lies to the left of 3, so -4 is less than 3. X can take a value of 2. Is 2 less than 3? Yes, so that's true. X can take a value of 3. Is 3 less than 3? No, so it's false. X can take a value of 10. Is 10 less than 3? No, so the response is false. Here's another inequality. X is less than or equal to 3. Given this inequality, let's answer the following questions. So this is a true or false. These are true or false questions. Now, x can take a value of -4. True or false? Given that x is less than or equal to 3, can x be -4? Is -4 less than or equal to 3? True. X can take a value of 2. Is 2 less than or equal to 3? Yes, because 2 is less than 3, so 2 is less than or equal to 3. I mean, 2 satisfies the less than component of less than or equal to. 2 is less than 3, so that's true. Can x take a value of 3? Is 3 less than or equal to 3? 3 is equal to 3, so true. X can take a value of 10. Is 10 less than or equal to 3? No, 10 is actually greater than 3, so false. X cannot be 10 because 10 does not satisfy this equation. 10 is not less than or equal to 3. This is false. X is greater than 3 is an inequality. And given this inequality, let's respond to these questions. X can take a value of -4. Is -4 greater than 3? No, so that's false. -4 is actually less than 3. So when x is -4, this inequality is not satisfied. X can take a value of 2. Is 2 greater than 3? No. So when x is 2, the equation is not satisfied. X can't take a value of 2. X can take a value of 3. Is 3 greater than 3? No. So x can't take a value of 3. X can take a value of 10. Is 10 greater than 3? Yes, 10 is indeed greater than 3. So x can take a value of 10. And this inequality will be satisfied. Here's a final example. X is greater than or equal to 3 is the inequality. This inequality is saying that x should take values that are greater than or equal to 3. If you look at a number line, so a number line like that starts from 1, 2, 3, 4, 5, 6, and so on. Numbers larger. This inequality says x takes values greater than 3. So greater than or equal to 3. So x can be 3 or values greater than 3. That's what this is saying. So x is 3 or any number greater than 3. So x is 3, 4, 5, 6, 7, 8, and so on. Any number greater than 3 or 3. Now, let's look at this. X can take a value of minus 4. False, because minus 4 is less than 3. Minus 4 will be somewhere on the left. X can take a value of 2. False, because 2 is less than 3. 2 is not greater than or equal to 3. So, x cannot take a value of 3. X can take a value of, 2. X can take a value of 3. Is 3 greater than or equal to 3? Yes. Given this inequality, x can be 3 or greater. So, x can take a value of 3. X can take a value of 10. Is 10 greater than or equal to 3? Yes, 10 is going to be somewhere here. 10 is in fact greater than 3. So, x can take a value of 10. And we're done. This video deals with an important technique for manipulating inequalities, and this technique is the swapping of the left hand side term and the right hand side term or terms of an inequality. And the rule is as follows: when the positions of the left hand side term or terms and the right hand side terms or term of an inequality are interchanged, so are swapped, the initial inequality symbol is reversed. And before we go into examples of applying this rule, which may not fully make sense now, but will shortly, let's look at the reverse symbols for these four inequalities. So for the greater than inequality symbol, the reverse symbol is the less than symbol. It's kind of like saying the opposite. Opposite of greater than is less than. The opposite of less than is greater than. So the reverse symbol for the less than sign is the greater than symbol. The reverse symbol for greater than or equals to is less than or equals to. And the reverse symbol for less than or equals to is greater than or equals to. You can easily remember them by thinking of the opposite. And you see how the information in this table is useful shortly. Here are some examples. This is a question. It says rewrite the following inequalities by swapping the left hand side and right hand side terms. So here's the first inequality: 7 less than 10. 7 less than 10 is an inequality because it's telling you that 7 is not equal to 10 and 7 is in fact less than 10. So we're just going to swap the left hand side and right hand side terms. So I'm going to swap 10 with 7. We're going to swap the positions, but remember the rule says when you swap the left hand side and right hand side terms of an inequality, the initial inequality symbol is reversed. And now we're going to reverse the less than symbol here. This less than symbol will be reversed to greater than. 7 is less than 10. You know that. I'm pretty sure you agree that 7 is less than 10. And you also agree that 10 is greater than 7. So you know that this reversal of symbols actually works and makes sense. 7 is less than 10. 7 sweets is smaller than 10 sweets. 10 sweets is greater than 7 sweets. You agree. So now we're going to try the next one. X greater than 3. We're going to swap the left hand side and right hand side of this inequality, and we don't want to change the meaning. So what you do, you swap the positions and you reverse the symbol, and that's all. Next one is y minus 3 greater than 6. Now I'm going to swap the left hand side term with the right hand side term. So I'm going to consider this as a left hand side term. Swapping gives 6 and y minus 3. Reversing the greater than or equal to symbol gives less than or equal to. Next question, or next inequality, is 6x plus 2 less than or equal to y. This is the left hand side term, this is the right hand side term. Swapping them gives y here and 6x plus 2 here. Now we have to reverse the less than or equal to symbol to greater than or equal to. And that's it. So when you swap the left hand side term and right hand side term of an inequality, you reverse the inequality symbol. This video deals with the multiplication of inequalities by negative numbers. And just before we go into that, I'm going to give you an example of an equation like x equals 2. Now, if this equation were to be multiplied by minus 1, so if it were to be multiplied through by minus 1, the left hand side term will be multiplied by minus 1 to give minus x, and the right hand side term will be multiplied by minus 1 to give minus 2. Now we're going to multiply inequalities through by negative numbers. The first one here is 1 is less than 4. We're required to multiply it through by minus 1. So similarly, the left hand side term is multiplied by minus 1. So minus 1 times 1. And the right hand side term, 4, is multiplied by minus 1 as well. But whenever you multiply an inequality through by any negative number, the sign, the inequality symbol, must be reversed. So this less than becomes greater than. And this simplifies to give minus 1 times 1 is minus 1 is greater than minus 1 times 4 is minus 4. And if we look at a number line, you'll see, let's have a look at a number line here. So this is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. Now, the initial inequality says 1 is less than 4. As you can see on the number line, 1 lies to the left of 4, showing that 1 is less than 4. Let's look at what the result of our manipulation. Minus 1 and minus 4. As you can see, minus 1 is greater than minus 4. And that's what this inequality says. If we didn't reverse the symbol and we just multiplied through by minus 1, so if we multiplied through by minus 1 and didn't reverse the symbol, we would have minus 1 less than minus 4, which is not true, because minus 1 is actually greater than minus 4. If you remember what I said in a previous video, as you move along the number line from left to right, the numbers increase. So minus 1 is greater than minus 4 because minus 1 is to the right of minus 4. So minus 1 is greater than minus 4. So we had to reverse the inequality symbol. So there you go. Here's another inequality. X is less than or equal to 2. And we're required to multiply this inequality through by minus 3, a negative number. So we multiply the left hand side term by minus 3. We also multiply the right hand side term by minus 3. But we reverse the inequality symbol. And this gives minus 3 times x is minus 3x is greater than or equal to minus 3 times 2 is minus 6. And that's the result. Let's move to the next one. The inequality here is minus x is greater than or equals to 2. We're required to multiply the inequality through by minus 3. Doing so is as follows. Multiply the left hand side by minus 3. Multiply the right hand side term by minus 3 as well. Because we're multiplying through by a negative number, the symbol has to reverse. The reverse symbol of greater than or equals to is less than or equal to. So simplifying this gives the following. On the left hand side, we have minus 3 times minus x, which is 3x, less than or equal to minus 3 times 2, which is minus 6. Let's move on to the next example. Here's another inequality. Y plus 3, so this is a whole bracketed expression, is a whole term, is less than 1. We're required to multiply this inequality through by minus 10. Well, the left hand side term is multiplied by minus 10, so this is minus 10 times y plus 3. And then the right hand side term is multiplied by minus 10 as well, so it's 1, or minus 10 rather, it doesn't matter, minus 10 times 1. And the inequality symbol is reversed. So less than is reversed to give greater than. Simplifying the left hand side, and the right hand side is minus 10 times 1, which is minus 10. Now, expanding this expression gives minus 10y minus 30. It's greater than minus 10. And it was done as follows. The term outside the bracketed expression is multiplied by the first term within the bracketed expression to give minus 10y. The sign, so I'll actually do it, minus 10y. The sign here is noted, and the term outside the bracketed expression is multiplied by the second term within the bracketed expression, which is minus 10 times 3, minus 10 times 3. And this gives, let's just do it here, minus 10y plus minus 30. Minus 10y plus times minus is minus, so we have minus 10y minus 30, which is what I have here. And then we have greater than minus 10. There we go. This is our final expression. Just to rewrite, we have minus 10y minus 30 is greater than minus 10. So that's what happens when you multiply through by minus 10. I haven't simplified. I could simplify by adding 30 to both sides. Even though the question didn't ask us to, I could. I put all the numbers together. And this gives minus 10y. Minus 30 plus 30 is 0. So great, minus 10 plus 30 is 20. And I could divide through by minus 10. So dividing through by minus 10. gives this, but the symbol here should not be the greater than symbol. The symbol here should be reversed to give the less than symbol. Simplifying this, minus 10 minus 10 1 0. This is minus 2, so we have y is less than minus 2. In this section of the video, we're going to look at the process of solving linear inequalities in one variable. Now let's take a step back. We've had equations of the form equations, and we've solved equations in one variable, like the equation x plus 1 equals 3. Solving this equation, which involves one variable, simply refers to determining a value for the variable that causes the equation to be satisfied. Now, and that's achieved by making x subject to formula, which can be achieved by getting rid of this plus 1 by subtracting 1 from both sides, which gives 2. So when x is 2, this equation is satisfied. Let's test it. If x is 2, we have a plus, we have a 1. This left hand side term is 3. The right hand side term is 3. They match. The equation is satisfied. But now we're looking at the solution of linear inequalities in one variable. Now, the way to do this is to simply make the single variable the subject of the formula. Remember, we're talking about a linear inequality with just one variable. So make that variable the subject of the formula, the subject of the inequality. This way you obtain solutions to the inequality. All relevant rules involved with manipulating inequalities should be obeyed. So if you're multiplying an inequality through by a negative number, remember to reverse the symbol. If you're swapping the left hand side and right hand side terms of the inequality, remember to reverse the symbol. So we're going to delve into some examples to make sense of everything I just said.